In this video, we're going to use a PhET simulation to balance some chemical equations. Now, our first equation is going to be the synthesis of ammonia, where N2, nitrogen gas, reacts with H2, hydrogen gas, to form ammonia, which is NH3. And if we're balancing a chemical equation, we have to assume there's at least one of each of the components. And by putting ones in front of each component, you can see now I have shown out one nitrogen molecule and one hydrogen molecule and one ammonia molecule. And you can see just by counting the blue circles that there are two nitrogens on the left and only one on the right. Also, there's two hydrogens on the left and three hydrogens on the right. And those are also represented up here in this bar graph. So I'm going to balance the nitrogens by putting a 2 out in front of the NH3. And note that now we have 2 nitrogens on the right side, just as we have 2 on the left, but also I have doubled not just the nitrogens, but the hydrogens on the right. So now instead of having 3 hydrogens, I now have 6. So what I can do is change the coefficient on the left to 3 H2s, and note that we now have 2, 4, 6 hydrogens on the left and 6 on the right. Really important detail here is the fact that I cannot change any of the subscripts. I'm only changing the coefficients out in front because if I change the subscripts, I'd be making it not nitrogen and hydrogen and ammonia. I'd be making other substances. So this is how I do it. Next, we're going to separate water. We're going to do the decomposition of H2O to form H2 and O2. So I'm going to do what I did before, starting with 1, 1, and 1. And we can see pretty quickly that I only have 1 oxygen on the left and 2 on the right. So I can double the oxygen on the left by putting a 2 in front of the H2O, which is nice, but I've also messed up the hydrogen. Again, I can't change that subscript because if I changed it from H2O to H2O2, I'd be changing it from water, which you can drink, to hydrogen peroxide, which you use as a disinfectant. So H2O I've changed to 2 H2Os. I now have 4 hydrogens on the left, and so I can double the hydrogens on the right, and now we have balance to this chemical equation. One last equation I'll look at is the combustion of methane. I'm going to take CH4, O2, and form CO2 and H2O. This is exactly what happens if you have a gas stove or gas heat in your house. It's burning CH4, methane, or natural gas. So I look here, I see the carbons are balanced, I see the hydrogens and oxygens aren't. Typically speaking, when there is an element that appears in more than one reactant or product, you want to save that to balance until the end. So I'm going to start by balancing the hydrogens. I make this a 2, and note not just the carbons, but also the hydrogens are balanced. However, I have 2 oxygens on the left and 4 on the right. With this in mind, I can change the O2 on the left to 2, and there we have it, our balanced chemical equation. So just for your work, it can help to draw out the molecules like this, as they're shown in this diagram here. So just something to keep in mind for when you are balancing your own chemical equations. If you can see it mathematically without the visual representation, that's fine. But if you need the visual representation, I think this is a very useful tool. And I encourage you to click the game here and play this game because it can be really helpful to you. So hope this video has helped. Feel free to leave any questions or comments in the comment section below, and thanks for watching.